Ductwork is the lungs for your air conditioning system. So make sure the lungs for your house are sized appropriately.
Ductwork, is it important? My short answer is yes. And if you want to learn more, stay tuned through the rest of this video. So I had a comment that I responded to. A customer was considering saying, hey, they were looking at doing a system replacement and they know that their ductwork is bad. Could they compensate bad ductwork with a higher efficiency system? And so it's like, instead of, with the base system, with, maintaining the ductwork that they have, can I compensate my lack of efficiency in my ductwork with a variable capacity system? My short answer to that is no. I would not go that route. I would much rather you prioritize ductwork than trying to compensate your efficiencies with the variable capacity system. There's a couple of reasons why. A variable capacity system does a really good job running and operating. It can help with those inefficiencies, but if your ductwork is in bad shape and you've got leaks, maybe insulation is falling apart, maybe it's not sized correctly, the bad ductwork is going to cause problems down the road, regardless of what type of system you have. And I'll kind of dive into a little bit more context. So in the 90s, the U.S. Department of Energy, the EPA, decided that they wanted to get into the HVAC business. And they wanted to get into the business in the form of like regulations and prioritizing higher efficiency systems to help with energy and whatnot. What that resulted in was you have systems that use less electricity to operate. However, components are smaller. They have different specifications. You have blower motors that have changed. You have outdoor units that have changed. But over time, there really wasn't a conversation about ductwork on those older systems. So whenever systems were replaced, and gosh, you have, in older homes, I would say probably 2010 and older, ductwork was not a huge priority in conversations. And so, because those older systems did not care about a special term we'll call static pressure. High static pressure is kind of like having high blood pressure. So on your unit, you have ductwork that's connected to it. If you have high static pressure, it's going to cause some strain on the equipment down the road. So it may be able to operate fairly well, but as that system runs and operates, it's not going to have as easy of a time running and operating efficiently if that system has high static pressure or high blood pressure. So over time, if the ductwork's not sized appropriately for that new unit, whether it's a variable capacity system or a single stage system, if the ductwork's not sized correctly, it's going to produce problems down the road. Anyways, EPA got into the ductwork HVAC business, and so we didn't have conversations about ductwork because we didn't necessarily know we needed to. And whenever manufacturers were changing the regulations and how they were dictating the efficiencies of systems, they're kind of doing it in like a perfect world measurement scenario where it's like ductwork static pressure was non-existent. And because static pressure was non-existent, the system achieved a certain SEER rating or efficiency rating. And as systems have been installed in homes, they found out that the way that they were testing was not nearly as accurate as what they were getting within like the labs. And so like real world application, it wasn't doing what was promised. And so as a company for, specifically with Yarbrough's, is we were looking at ductwork and sizing ductwork correctly for the equipment, regardless of whether or not it is a single stage or a variable capacity system. And so whenever you're looking at a system and you've got ductwork, a few reasons why you would either change your ductwork, add ductwork, or replace your ductwork is one, your ductwork's compromised in some way, shape, or form. The ductwork needs to be replaced because it's either insulation's falling apart. Maybe you've got a ton of leaks over time. Maybe we've had situations where critters, animals have gotten inside the ductwork and it kind of tore it up. And so at that point, it makes sense to do some replacements. Or the system is the new system that's being installed. The ductwork that's there now, there's not enough of it to compensate for how strong that new blower motor is. And so a lot of time on most homes that we're going into, we're not necessarily having to replace all the ductwork, but we're having to compensate specifically on the return air, and then we'll compensate on the supplier when we need to. And so, but most frequently it's just return air. So to kind of full circle, go back to the main question, which was, can I compensate with a higher efficiency system to overcome bad ductwork? And my answer is no, I wouldn't recommend doing that. I'd much rather you spend money on doing, like I'd rather do a single stage system and correct all of your ductwork problems, as opposed to doing a variable capacity system and maintain the ductwork as is. And so, because over time, you're going to have more problems. Best use of your dollar spend is to tackle airflow, the equipment, and then airflow. And then if you want to do a variable capacity system, that's going to make a huge improvement. To kind of talk a little bit more about static pressure is, in terms of blood pressure. So we'll say, we'll just say horizontal unit, sits up in the attic space. So let's say you have a furnace and then you have a coil. So we'll just say F for furnace and C for coil. Here's your supply ductwork. So we'll just say supply, and here is your return air. So we'll say R for return. So your supply ductwork supplies to every room. You have ductwork that comes off, just like so. You got ductwork that goes all throughout the house. And so let's say your ductwork on your supply side is, obviously we want to make sure that these are supplied correctly. We kind of treat the furnace is that kind of is what dictates, as far as static pressure is concerned. That would be what I would consider kind of the heart of the system. And so if you have high static pressure, then you're going to have, I would say, high blood pressure. And so that it's going to be really, really difficult for that system to run and operate if it is designed to run at a certain static pressure over time. And so it may run and operate, but it's not going to do so efficiently. And so your return ductwork is going to look like you may have 1, 2, or 3 coming off. You want to make sure that the ductwork coming back to this system is sized appropriately. And I'm actually going to kind of dive in to a little bit of the math. So let's say that this system is let's say it's a 3-ton. So this is a 3-ton system. So you have a 3-ton blower. And so your 3-ton blower, and I'm just going to use kind of nominal CFM verbiage. I understand that it kind of changes manufacturer to manufacturer. However, a 3-ton system, most of the time, you're going to have a furnace that can handle 1,200 CFM. So that's cubic feet of air a minute. So that's what that stands for. So that furnace can handle 1,200 CFM. Now, whenever we're doing our calculations, and let's say, and this is a hypothetical situation. This is a hypothetical home. So most of the time, we may see a 14-inch return here. We may see a 12 or 14. And so we'll just say for goodness and giggles, we'll say 14. And so 2 14 inches return air. And at Yarbrough's, we design our ductwork off of a 0.05 static. And so it's basically like it's as little friction as possible. And so that is the standard that we like to use. Manufacturers will have their static pressure recommendations. And so for us, we felt like, shooting for that 0.5 static pressure is what's going to allow for that system to run as free as possible, because we want that unit to not have any friction when it's running operating. So 2 14 inches will run at a 0.05 static pressure, and the rough CFM of those at a 14 now will be somewhere around about 500 CFM. So 500 CFM. I understand that, okay, well this furnace can operate at 1,200 CFM, but I only have 1,000 CFM going back to the unit. So the recommendations that we typically go back with, and this is what I shoot for, and this is just a general practice that we have. So you could do a 10-inch, you could do a 12-inch, you could do a 14. What I typically like to do is, let's say this is connected to a 24 by 14 inch grill, 24 by 14 inch grill. I like to keep all the filter sizes the same. And so as long as access allows it, I'll just do 24 by 14 inch grill, which will, and then I'll do a 14 inch going back to the unit. And what that will do is that will achieve 1,500 CFM, which is well above 1,200 CFM, what that furnace is rated for. So what that means is that you've got plenty of air going back to this furnace. So that way, whenever it kicks it off to the supply, you've got plenty of airflow going that way. Whenever I'm calculating all this ductwork, a lot of times, especially whenever I'm diving in, we use what's called a Ductulator. Anyways, it's a fun, it's a duct sizing calculator. You'll notice that this specific calculator it adjusts for flexible ductwork, and it also has galvanized metal ductwork. And so I do like to whenever I'm looking at ductwork, I look at the flexible duct and what the static pressure rating is for. Now, so an 8-inch ductwork, so I'll set my size here, 8-inch, and then I'll look for my static pressure. An 8-inch at a 0.05 static pressure will do roughly about 100 CFM. And so if I was designing all the ductwork, which is what I did with my house, so 8-inch will do 100, and then let's look at our 10-inch. What does that one do at a 0.05 static? 0.05 static, that's going to do 200. Whenever I'm looking at the calculations, I'm like, okay, well, how much how much ductwork do I need to add? It's like, okay, how do I do that? So you get 1200 CFM. The sizing of the ductwork will help dictate how much airflow that system is rated for. And so whenever I'm looking at a retro house, if I'm designing it, I will design that ductwork accordingly, room by room. And this is not necessarily a good representation of the different rooms and how much ductwork you may have on your house, but it gives you a good idea of how that is calculated. So I'll go through and I'll calculate each supply and go off of that. But to simplify it, to make it easy, whenever I'm looking at ductwork, I'm looking at, okay, how much return air do I have that I have available for the existing system? Okay, is that enough for the new system that I'm putting in? If the answer is yes, then awesome. We don't have to do anything with return air, and question is the same for the supplier. Now, if I'm looking at the existing system and the ductwork for the return air is not enough, then obviously we're having that conversations of we need to increase return ductwork so that way that system runs efficiently. And so and then the same thing on the supply side. And so I go through that calculation. It's like, okay, well, how much supply ductwork do we have? How much CFM is being produced is available whenever that system's running and operating? And then do I need to add any more to help get to the ideal static pressure on that furnace? And so those are the calculations that I'm doing to help it to try to achieve that. And so I hope that was super informative and helpful, and I hope my drawing made sense. Don't neglect ductwork. It doesn't matter how fancy of a system you buy. If your ductwork is not sized appropriately, then that new system or the existing system is going to struggle to run and operate. It is the delivery system that brings you comfort when you need it the most. And if your ductwork's not sized appropriately, then you're not going to be comfortable in the way that you need to be comfortable. For any of you that are in the Oklahoma City metro area, if you have questions about your ductwork and are concerned whether or not it's sized appropriately and need estimates or just general service, then we'd love to be your team. And so there's this little QR code over here. Give us a call. We'd love to be your team. Thanks.
Yarbrough